Hello and welcome to our week 3 voiceover lecture. So today we will be going over chapter 3 from the textbook on analytical epidemiology in community and public health. So this will just be a brief overview of some of the chapter 3 concepts. So make sure you read the chapter and review all of the slides to complement this voiceover lecture. So let's jump right in. So we are going to get started with some of the common types of studies used in epidemiology and health promotion. Two major studies used in analytical epidemiology are observational and intervention studies, which are also known as experimental studies. In an observational study, you are looking at or observing the factors under study. You do not manipulate them in any way. There are two types of observational studies. The first is case control studies, where you compare individuals with the health condition and individuals who do not have the health condition to examine the differences in risk factors or possible exposures. An example would be looking at a group of individuals who are diagnosed with lung cancer and another group who does not have lung cancer to see if there are any common factors. So this is retrospective because you are looking back in time. The second type of observational study is cohort studies. This is where a group of individuals who share an exposure or risk factor are followed over time to assess the development of the health condition. One of the most well-known cohort studies is the Nurses' Health Study. This study started in 1976 and is now enrolling nurses for its third generation or cohort. Up to date, it has included up to 275,000 participants. So this is a prospective study because it is looking forward. So here's a quick chart to help visualize the different studies and when they would take place. As mentioned before, a case control study is retrospective, so looking back in the past, and a cohort study is prospective, which would be following the group forward over time. Next, we're going to talk about intervention studies, which include experimental designs like clinical trials. These are also prospective. Okay, so our intervention or experimental studies, these involve manipulating a variable. A classic example is medicine or a clinical trial. One group of participants gets a drug to try and another group gets a placebo, and the results are compared. In health behavior, a group will get a specific program or intervention and would be compared to a group that didn't receive the intervention. There are a few different types of intervention studies. Randomized clinical trials, or RCTs. So like mentioned before, you would have two groups of individuals. One is the experimental and one is a control group. Ideally, the participants don't know which group they are in, and you randomly assign the groups to individuals. You can also blind those conducting the measurements to ensure that the results aren't skewed. This is usually randomized by the individual. It is a little bit more difficult to conduct blind studies like this in public health because likely the participants will know if they are getting a program or not. But you may give one group nutrition education with a Zumba class while the other group only gets the Zumba class and compare. Maybe which one was more likely to change their eating and physical activity behaviors. So now when you are randomizing by a whole group or community, it is called a randomized community trial. So the factor under study is manipulated and then given to two or more communities. It is still assigned randomly, so both communities have an equal chance of being assigned either experimental or control. This may be when you're assigning maybe media campaigns to school districts. Now, a quasi-experimental study is when there is no random assignment between the experimental and control conditions. There may be ethical, practical, or convenience reasons for why a random assignment could not take place. So let's go back and explore case control studies. Again, these are retrospective, going back in time. There are two groups, the cases, which are the individuals who have the health condition and controls, and individuals without the health condition. You are looking back in time and asking about exposure or other potential factors that might relate to the condition. So here's just a little chart to help explain explain that a little further. I kind of like visual charts. They help me conceptualize terms a little better. So here are steps for conducting a case control study. You have to be very specific when selecting cases. So this is identifying the inclusion and exclusion criteria. You want to be very purposeful when selecting controls because the next step is matching. You want to match as much as possible by age, sex, ethnicity, and any other variables. This won't be 100% perfect, but the closer you match, the more confident you can be in understanding the exposures that may have led to the health condition. After you do the matching, you want to measure the factor under study. You may do a questionnaire, conduct interviews, or review health records. So one example of a case control study is if a cruise of 300 people arrives back in port and 150 people are sick with the same symptoms, an epidemiologist would begin asking everyone questions and may determine that almost all of the sick cases ate potato salad from the buffet, and most of the controls, which were not sick, did not eat the potato salad. In this situation, individual matching was important, but the matching between cases and controls was the fact that they were all on the cruise at the same time. Another very popular case control study took place in 1976 after an annual convention of the American Legions being held in Philadelphia. They started seeing a dramatic increase in pneumonia-like symptoms. So the CDC was called in and they started surveying all of the individuals that were sick and noticed that a great deal of them were Legionnaires with the American Legion. From there, they continued to survey all of the Legionnaires and found that the disease was prevalent among those that had attended the conference, as opposed to those that did not. They ended up tracing the disease back to the hotel, and about 34 individuals had died after all was said and done. So, when outbreaks like this happen, a large case control study may be conducted to try and quickly identify the causal factors. So here's an example of a histogram that tracked the case of Legionnaire's disease, and you can see how the incidence of disease spiked right after the convention. Now, here is a chart you would use to track a case control study. So you see the columns identify whether an individual is a case or a control. So do they have the condition or not? Then the study factors are labeled in the rows. If looking at those with the health condition, how many of them had a particular exposure? Now compare those that are healthy and how many of them had that same particular exposure. You will use a chart like this in your biostatistics course, and it's a nice way to do a chi-square analysis. So here's our chart again using our cruise example. So you see the columns identify whether an individual is a case or a control. And so in that instance, the cases are those that were sick upon arrival at port, and the controls were the people on the cruise that were not sick. On the side, we have our study factor, which is those who ate potato salad and those who didn't. So once you put all the correct numbers in the boxes, you can calculate the incident rate, which is seen on the far right. As you can see, the incidence rate among those who ate the potato salad and got sick is much higher than those who didn't. Here are some advantages of case control studies that you can review and the disadvantages of case control studies. So going back to cohort studies, this study is a group of individuals who share a common characteristic. This may be a birth or an age cohort of individuals, so they're born in the same year, a school cohort, which is like your group, so you are all in the same MPH cohort. Again, this is prospective, so starting now, we're looking into the future as opposed to back in time. So here's the chart for a cohort study. What's different here in this chart is you can look and see which outcomes develop and those that don't develop it. Now, our type of cohort studies. So we've been discussing concurrent and prospective cohort studies, which is usually what most cohort studies are. Now, you can have a retrospective cohort study, which goes back in time, but this would be much harder to do, so you would need to have all of this data to actually conduct this. And here you can review the advantages and disadvantages of cohort studies. So now we are going to go over randomized clinical trials a little bit more. Again, the study factor is manipulated, and there are two groups, the experimental and the control groups. Ideally, the participants are blind and don't know which group they are in. The study factors may be drugs or treatments for a disease, a preventive agent, a community or public health program or screening program, or it could also be a medical or surgical procedure. The advantages, especially with randomized clinical trials, is that they are considered the gold standard in evidence-based medicine and practice. And this is because everyone has an equal chance being in either group. So statistically, this helps us get a better idea of the causation. Did the factor being manipulated influence the outcome? You want to make sure you select and monitor the participants very well. It also provides effect sizes so you can look at the strength of association and how much did the type of manipulation influence the outcome that you are studying. So, a few disadvantages of a randomized clinical trial is that the participants may not be fully representative of the target population, and it may not be a realistic situation. So, you have to keep that in mind. And here it just talks a little bit more about the randomized community trials and the quasi-experimental studies. Statistical association. Now, talking about the strength of the association, when we talk about the statistical association between two variables, the factor may be whether or not they receive the intervention and how that relates to the health outcome. Statistical association is understanding the relationship between two variables and how they are related by chance. So we would look at the p-value, and a standard p-value is 0.05. So how you interpret that is after conducting all the statistics, there is a 5% chance or less that this relationship happened by chance. This is because there is always a chance that things are randomly related. However, we are 95% sure that this association is not by chance. So we also want to make sure it was a true relationship. So we want to rule out bias and confounding factors. Selection bias happens when the participants are included in the study in a way that differs from those that aren't. An example of this is posting flyers searching for research participants, and those that end up calling and asked to be in the study are systematically different from those that don't call to be in the study. They are self-selecting to be in that research study. Information bias can happen if the interviewer knows the identity of cases or controls, and this can lead to systematic error. If someone is behaving in a way that is impartial, so they may be influencing them in some way based on how they ask the questions or maybe read the measurements. Recall bias happens because it can be hard to recall exact details. A good example is if you were given a food questionnaire to recall everything that you ate last week. That is pretty difficult to recall. So your experiences, they shape the things that you remember, and that is a recall bias. Confounding variables, these are often referred to as extraneous variables, and it is related or confounds the relationship between the study factor and the outcome. The example listed here discusses studies that looked at coffee drinking and coronary heart disease. But later, the study found that it wasn't really about coffee, but smoking. So coffee was related to smoking, not coffee causing coronary heart disease. It was actually the smoking. Another classic example is ice cream and murder rates. Ice cream sales are positively correlated with murder rates. So the more you sell ice cream in an area, the higher the rate of murder. There are a couple of explanations for this. So does ice cream cause murder? Or maybe murder somehow influences the need for ice cream, but neither of those make sense. There's a third factor involved, and that's as the weather gets more hot, more people are out and about, and more people are interacting, which influences the murder rate. So weather would be the confounding variable. Basically, this is just to remind you that you can't look at two random variables and automatically assume that there is a causal relationship. Here are the criteria for causation, which you can read about more in your textbook, as well as the following slides that cover infectious disease epidemiology, so infectious diseases, communicable diseases, and contagious diseases. And these are the routes of transmission for infectious diseases. Here we discuss further chronic disease epidemiology. So just make sure you review all of these pages in your textbook. Lastly, there is the skill building activity at the end of the chapter. And as always, this is optional, but these are just a great way for you to practice and make sure that you really understand the concepts that you have just learned about. So this can be found in page 116 of your textbook. So that concludes our week 3, chapter 3 voiceover lecture.